facts are subject to interpretation.
Mhm.
Because,
That's
you know,
what
you
I
have to
think.
start from like first principle. That's why I said if you don't know how to determine the truth, you know, so for instance, if you try to start and like reconstruct flat earth versus globe, and you start from the beginning. Hey, dude, I ain't gonna listen to what anybody said. Start from the beginning. Okay. So start from first principles. What is the observation of the earth? What do I see? Looks flat. Okay, fine. What's next? How do I determine whether that's true? First of all, why are you even doubting it? Why would you even doubt that that's what it is? What's the evidence that that's not the case? Like the globe Earth can't even get past that point. So the thing is, you can't construct a logical argument for the globe at all because you don't have the first step, the observation. Right? You always have to start with the assumption. If Earth was a globe, what would happen next? Right? You don't start with, man, the Earth looks like a globe. You know, yada, yada, yada. That's why this is that. And that's why this other thing is this other thing, right? So you have to start with an assumption because it's not experienced. Right? So it's constructed in the mind. It isn't perceived with the senses, right? Because we either have our senses or our mind, right? That's the only way we can gather information about the world. Would you agree with that?
Yeah, I'd agree with that.
So the globe's starting point's the mind. And the flat earth starting point is perception. So when you start with the mind, you can imagine any fucking thing. That's you know, that's all possibilities. Whereas perception is limited to what human beings perceive. So we've narrowed it down. Hey, what do we perceive? But if we start with imagination, that could be anything. And then how do you go from the imagination? Hey, I can't, I think it's this, but I can't perceive it. How do I figure out what I imagine is actually true when I can't get the physical, when I can't perceive it?
I just have also a
See, that's
question.
what I mean by
Is it-
first principles,
Yeah,
because this is a Gordian knot, right? To untangle,
yeah.
right? And this is why this topic goes back and forth, and because we're Globers versus Flat Earth, there are two different starting points. If I'm being generous, it's two different starting. Now, obviously, most people just believe it's the globe because they were told it. But if you try to actually take the intellectual, rational position and try to say, hey, we're gonna work through this problem and figure out what's true, then the first principles from which you do your analysis matter.
I just have a quick question as well for you. Like, who's the most hardcore, like, flat earther here? Would that be like, who would you say is?
Me.
Indio.
Okay, so if I took you up, let's say I took you up to space, we went all the way up.
Every fucking
Me, I'm the
time,
hardcore
bro.
one called space. I'm the hardcore
I
one.
know, but I know. Just
What if I
go
took
with
you to
it.
the beach?
Yeah.
That'd be the best
I-
offer he's had
don't
all
really
week.
You literally
I don't
saw
really like
flat
the
Earth
beach.
your whole life and don't believe it, bro. But you want to
I
take
don't
me
really
to
like the
somewhere.
beach.
No, you've seen a flat Earth your whole life and don't believe it. But you're saying you could take me to this imaginary place, and yeah, if you see the globe, you should believe that. Why don't I just deny that the same way you've been denying flat Earth?
I do, but go with my question a little bit.
I think I gotta see the globe every day. How old are you? For 29 years or whatever you are. I gotta see it every day
I'm
for
20.
29 years. Then I'll believe it's a globe.
Okay. I just have to ask you one question though. Like, go with the analogy real quick, or the hypothetical situation. So I
Yeah,
take you
if
up to space. and you see around Earth, it's a globe and everything. And then you come into here and you say, I've seen the truth. It is a globe.
I've seen the truth. No, I
Yeah.
say,
Yeah.
hey, I went to
Oh.
space. I looked at the Earth and it looked like a sphere. That would be
Yeah,
the truth.
Check the
Yeah,
side chat,
right.
Stitches.
You see what I said? It looked like? Just like the Earth looks like it's flat, but you don't believe it is flat? I can play the same game. I could say it looks like a sphere, but actually, it's just a sphere that's so big it's actually flat, right? So a sphere of infinite radius is flat. I'll just say that.
Just reverse the idea. He took you up into space and you saw the Earth being flat. What would you do?
Then I'd say it's flat.
Yes, what's
Oh,
underneath
thank-
it?
Yeah.
Only from space. See, you can only determine what reality is if you go far away from the Earth. You can't do it when you're here. You got to go to the magical space place.
Yeah, like if I took you all around,
Yeah.
like the entire perimeter of the Earth,
Do
If
you
we could put
understand?
Professor One
Remember when
into a
I
castle.
started? I said the first
I know.
principles that you have to start
I know.
in concepts and ideas.
Yeah.
Space, as far as you're concerned and I'm concerned, it's a concept and an idea. It doesn't exist in any reality. And you think that somehow you can go to the place which is a concept to prove reality.
Well, let's say it's not a concept for just like this hypothetical situation. It's hypothetical. I take you all around. I take you around the entire perimeter of it, and then you come here and you'll say it's globe. Would anyone here be willing to accept that from
I hope not.
a hardcore?
I hope not. I
But would
really
you?
hope not. Why should they?
They should take one of their most hardcore person's words.
So you
as
base
the
truth based upon the words of a stranger. See, this is the fundamental problem, man. You found the problem. Okay? Regardless of what I tell them, I could go up to space, see the Earth as a ball, come back down and say, hey, Jedi, I went to space, I saw the Earth as a ball. Now, Stitches, would he know the Earth is a ball, or would he just believe it?
I'd say you'd know because it's a first-hand experience and you've been up
Now,
there.
I would know if I went, but he wouldn't know.
Then we'll just take Jedi with us, for the fun of it.
Oh yeah, and then he'd come back and tell somebody else, and then they won't know either.
Then
This
we'll
is the
take
fundamental
everyone.
problem is it's a belief system. The globe is a belief system. You just pointed out the fundamental problem is that you don't think that you can figure it out yourself and that you have to believe the claims of strangers.
What if we get a video of it as well and it shows it being round?
Yeah, but then you have to believe things about the video.
What if the video is undoctored, it's unedited, and it's
How can you tell that?
factual?
What type of analysis can you do to video to figure out what's in the video actually depicts reality? Nothing. There's nothing you can do.
We can see if there's any jump cuts in it. We can see if there's any AI detection. We can see other things of that.
Yeah, but there's look. The biggest way to fake video and pictures is to just label them wrong. Right? You take a real photograph of a painting and then say this. Look, you take a real photograph of a painting. So say you have a hyper-realistic painting of Morgan Freeman. You take a photograph of it and you say, hey, look, dude, this is a photograph of Morgan Freeman. No, it's a photograph of a painting of Morgan Freeman. It's not Morgan Freeman. You understand?
I mean,
all I did was caption it wrong. Now I could take a photograph of a globe, a painting of a globe Earth, and it would be a real photograph. 100%. You could examine it. You could examine the fucking film. You could look at it with a microscope. It would be 100% real film. But it doesn't mean what's on the other side of the camera is what I say it is. Okay. But you know what we can do? If we take a photograph of the Earth, can we test what's in the image in reality? Like check this out. So say we went to New York City and someone showed us a photograph of the Eiffel Tower in New York City in the middle of Central Park. We could go to Central Park and see if the Eiffel Tower's there, right?
Yeah.
And it wouldn't matter anything about the photograph. We ain't got to prove the photograph's fake or anything. If we go to Central Park and there's no Eiffel Tower there, we know whatever that thing is, it doesn't represent reality. Right? So we can do the same thing with their photos. Whatever the photos are, we can check to see if what it shows in the photo of what the Earth is actually exists in reality. And you have a whole bunch of evidence, which you just said, that show that the curbing water, the curbing ocean, all that stuff doesn't exist in reality. Exists in imagery. That's all. That's the only place it exists, in concepts, on screens, in picture books, toys in the corner of the classroom. But with a place where it has to exist is out there in the natural world. That's where it needs to exist. And no matter how many people, if I go do my own tests and I go, hey, dude, there's no fucking curvature to the water. I don't care what the fuck they show me. They can show me pictures. They can show me math equations. They can show me whatever the hell they want. Doesn't matter. Is it going to falsify the observation? So I'm looking at nature. I'm not like going into this abstract concept of like ideas about what the world is, right? When I don't have the basic natural evidence that's in the natural world to support my ideas. Science always comes down to empirical observation. It doesn't matter what fucking people say. Do you understand that we invented science and the scientific method so that we don't have to deal with bullshit like this? People claiming they did stuff. People saying they got this result. It has to be testable, repeatable, verifiable. So that means if someone says, hey man, I mixed these two things together and it exploded. Okay. I should be able to mix those two things together and it explodes. If I do the exact same thing as them, right? Has to be testable, repeatable, verifiable. But ultimately, if that person just wrote down an equation with the two substances and said, boom, two things go together, go boom, that would be even less valid because they wouldn't even have even in an empirical starting point at all. Science is empirical. It's not based upon ideas, thoughts, rationality, theories, explanations, just those stories or anything like that. It's based upon tests done in the natural world. And this is where I think the Western civilization has really gone wrong in the last 100 years, is because we've gotten away from experiment and gone into fucking la la land of theoretical physics. I mean, we've had Jedi can attest to this. We've had people in here with science degrees talk to us that don't know what the scientific method is. It ain't our version of the scientific method. It's the scientific method that's in the fucking textbook. We had somebody last night. What did he say? He said, the first thing you do is an observation and then you start modeling it. It's the fucking dumbest shit I ever heard. Science isn't
honestly
models.
interesting to hear this.
Well, I mean, not enough scientists took the philosophy of science. You can't do science without certain prerequisites, right? You need logic, right? First thing. Do you need logic to do science?
Yeah, I'd say you do. You need some form of intelligence.
No, actual logic, not just intelligence. Reasoning, logical reasoning.
Yeah, I'll agree with you on that then.
So the reasoning, the logic comes first. You can't do science without it. And the reasoning behind science is empiricism. is that facts about the natural world are known by testing the natural world. They're not known by thinking about what should happen in the natural world. They're known by actually doing it. So if you have some theory or some hypothesis about something that happens in the natural world or some fact about the natural world, the only way it's considered a scientifically valid theory or hypothesis is if you do the experiment. Until you do the experiment, you're just talking.
I see. I see what you mean.
You agree with that?
Yeah, I agree. You need actual verifiable. You need to do the tests.
Yeah, or
In
it's not
actual-
science. Anyone can sit there. Me and you could smoke some fucking weed and just talk about, oh my God, what if this? What if that? Well, that's
People
not
still die.
science. Speculation
we-
isn't science. Imagination isn't science. The scientific part is the actual experiments. That's the scientific part.
It is rather fun though to speculate as well. I can't lie. I do love thinking of theories.
That's fine. But the thing, when we get to this, the main problem is in modern day, because of just in the modern society, when people hear something is based upon science, they hear absolute truth. That's what they hear. Oh, it's the scientific consensus. They hear that's the absolute truth. They hear it's scientifically proven. They hear that's the absolute truth. Not knowing that the real science is the experimental result. And though you have an experimental result that does something, I do some tests, I get some result, I have measurement data, all that crap. That ultimately has to be interpreted by a human being. Okay. And then you have your assumptions, right? Your presuppositions about what that data might mean. And it could mean, and it could fit your hypothesis, but that doesn't mean exclude other hypotheses. Just because you have a story that fits, it doesn't mean all the other stories are wrong and yours is right. But
Yeah, I
this
can
is
definitely see what you mean in that.
yeah, and these are like if you went to the philosophy department of any university and talked to the people teaching philosophy of science, this is all well known. This isn't stuff I'm making up or invented. I'm not being super smart. I just happen to know about it. And it's been known that the modern science uses inductive inference reasoning and all of that. Any type of reasoning done doing this method has the logical fallacy of affirming the consequent, right? So, for instance, if the Earth's a globe, ships will disappear over the horizon. Ships disappear over the horizon, therefore Earth's a globe. That's affirming the consequent. I could equally say, if the Earth's flat, ships should disappear over the horizon. Ships disappear over the horizon, therefore the Earth is flat. Affirming the consequent. Almost all scientific claims have this packed in it. But they don't tell you this because it's will to power, man. Don't underestimate that people espousing to do science that aren't actually doing science are really just doing what they do for power.
There's a lot of power in like the sort of things we talk about and the sort of information what we give out.
Well, I mean, which one do you think will get a better girlfriend or a hotter girlfriend? All other
Probably
things being
Globin.
all things being equal, the rocket scientist or the electrician?
Probably electrician, just based off how
The
sometimes
electrician. Even though the rocket scientist can make like 7 times more than the fucking electrician
He doesn't
and
come on
have
a light.
status. And have status. That's the thing. Oh, what's your husband do for a living? Oh, he works at Rocketdyne. He makes rockets. He's a rocket scientist. Oh, what's he do? Oh, he works at frickin' Frandan Electrical and fucking wires fucking sockets. There's no status in that. I'm not putting it down. I have more respect for that than the rocket scientist. I'm just saying that there's a power play in this shit.
There's always going to be some sort of power play in any sort of like job. Like electricians,
In,
they have the
in
power to
society,
just
well, do you agree? Do you agree that in society, rocket scientists is considered more of an accomplishment than an electrician?
in society, yeah, I would agree.
Yeah.
Yeah,
But I wouldn't agree on a fundamental basis because, yes, rocket science do a lot, but we also have electricians.
we're talking about what a woman would choose, dude.
I
Talk
know.
about what a woman would choose. And status, and
But-
money. All things being equal, they're as good looking as each other. They're the same as each other. The only difference is the job that they have. From a woman's point of view, going rocket scientist because it's cooler.
It is cool. I'm less risky than an electrician. Do you know what the most common death for electricians are?
Driving to their job.
I was going to say microwaves.
Suicide, depression.
Suicide.
Yeah, also that. Also that. But for like on the job death, it's mostly microwave because the transformers in there, if it's not turned off, then they release a high voltage, high amperage, high frequency.
Are you talking about near field coupling?
Yeah.
Yeah. You know, and you know that this is a whole other thing. I don't want to go down this road, but near field coupling itself. No, it's known about in physics. It's not really worked out. Meaning, so you have electromagnetic radiation. There's near field and far fields, but they're all concerned about the far field radiation, right? Photons and all that shit. Right, speed of light and all that crap. Like think of anything you hear about science, right? Is general relativity and black holes and speed of light and all that crap, right? Lasers, phasers, da 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 da. But that's only half the story. That's transverse waves that have left the the emitter. But at the emitter itself, like you said, these alternating currents they oscillate, right? So what will happen is you'll get too close, you'll get within, it's called like 1/6 of the wavelength that's being emitted, and you'll couple to it and you'll fucking fry. It'll transfer energy right into your body faster than the speed of light. I hate to tell you, it's instantaneous.
It's pretty instant.
But they don't talk about that it's instantaneous. It's a whole field of science that's freaking just abandoned.
We do need
It's
a
not
lot
sexy.
more research in things. Not gonna lie. Like I majority focus on biology than anything else. That's the main thing I focus on. And neurology.
Electricians
love
die of
neurology.
AIDS. What the fuck, man?
Hey, I mean, is there AIDS in electricity? Who knows? Who knows?
Maybe I have to take that back, man. Maybe the freaking electricians are getting laid more than the rocket scientists. They're dying of AIDS. Wait, I don't know.
The electrician community is going to have an absolute field day with you. You know that, right? As a carpenter.
No, no, let's not go into carpenters. Wood jokes. Not going there.
Okay, so Jesse, your problem is that you're stuck in theory too. You've never looked at what the actual data for the study of terrestrial refraction actually shows. Doesn't show the bullshit that you anti-flat earthers say. It's nothing even close to that. I actually found it yesterday. Shit, yeah. Hold on, I'll read something to you. I found this old post. This is from Simulation Study of the Refraction Effects. K. Beckett, School of Surveying, University of New South Wales, Sydney, Australia. The abstract. The atmosphere, an optical environment of electromagnetic observations, has an unstable and chaotic structure, which is also seen in the refraction effect of electromagnetic radiation. For over 300 years, hundreds of models were created describing the influence of refraction effects on the results of geodetic observation. So far, no universal solution has been found which fulfills precision requirements of geodesy. Short story is, you have no fucking idea what it does. There's nothing to disagree on. There's no model that makes accurate prediction. No one knows what the fuck is happening. Okay? All we can do is make qualitative descriptions of seeing shit. There's nothing quantitative. All the quantitative shit I've ever seen shows that what you guys say is 100% wrong.
Well, I recognized in my opening paragraph that we may not agree that there is a possible way to measure drop over distance, but my question wasn't about refraction. It was saying, if, for the sake of discussion, that there was a way to measure drop over distance, would this be a genuine experimental procedure?
Scientific experiment are looking for causes of phenomena. Now, this is a measurement using very scientific tools, and we're going to try and be very, very accurate.
I'm gonna just ask you the same thing I've been asking all you guys, and I have not got a straight answer in 3 years. What is the justification for you thinking terrestrial refraction does fucking anything at all? Other than that's what you read in the textbook, or you read online, or you read on the webpage.
Does anything at all?
Does anything at all? Yes.
You mean
And
like...
we know there's we know there's refraction like twinkling stars, right? Scintillation. Okay? But you guys have gone further and says like it's bent in a direction. Okay? It goes in one, either, it gets bent in a curve. There's no evidence for that. There's no justification for saying that. There's nothing. If that's what I mean. You guys say, "Hey, man, I hear this, and I'm sure you've said it with your own freaking mouth. Is you guys didn't account for refraction?" And I say, "Oh, how do you do that?" Nobody knows. Nobody can tell me how to quote unquote account for refraction. How do I do that?
Just apply 7/6R like the globers do. It's easy.
Yeah, exactly. There's nobody can tell me how to do that. So if you can't tell me, if you can't say, "Hey, dude, this is how you do it," you don't know what the fuck's going on, and you have no justification for including it at all. So if you have no reason to include it because you don't know what it's doing, I'll just exclude it. Until someone gives some valid substantiation, okay, to some general refractive condition in the fucking air that's happening all the time. It's just a bunch of fucking hot air. You didn't account for refraction. How? How? And when I say how, I mean anyone can make a model and quote unquote account for refraction, but that model actually has to be able to make predictions, right? Predictions. So before you do the experiment, right, you say, hey, dude, this is the weather conditions. I'm going to punch the meteorological conditions into my fucking model. Blah, blah, blah. Okay, this is this far away. We're going to push the fucking button on the camera, and the image in the camera should look like this. No one can do that. You know no one can do that. Or in the reverse, take the picture and then get the meteorological condition, get the picture and be like, okay, this image is displaced this much. Here's the meteorological conditions that existed. Then go check to see if that was the actual meteorological conditions. Then you would have a predictive model. So no one can do any of this crap. And then there's all the other things, the other problems you guys don't want to deal with. Okay. Dispersion, where's that? Vignetting, where's that? All the effects we have that we have to compensate for in lens design, because lens design deals with high refractive elements, and that's what you guys are saying, that the fucking air is this gigantic refractive fucking lens. We don't see magnification. We don't see all these other effects that would happen if refraction was going on. Where are those? There should be other indicators other than something as higher than it's supposed to be, or lower than it's supposed to be, or flatter than it's supposed to be. There should be other indicators of refraction that we could see, measure, all that shit. But I don't see any of these. I don't see it quantified in the scientific literature. I don't see it anywhere. The only time I've ever seen it is the Bricker fucking paper, where he modeled, hey, dude, there should be this much dispersion over these 147 kilometers. And there wasn't any. What are you showing me, Jesse?
Dispersion, chromatic aberration, or chromatic dispersion.
Yeah, we know what it is. Some
What's the
lenses
light
do it worse
source?
than others.
What's the light source?
One is the sun, and the other is a snowmobile headlight.
Okay, yeah. Astronomical objects have dispersion. Okay, terrestrial objects don't. Your snow, your what do you call it? Your snowmobile headlight, whatever it is. Do you think that that's white light, like the sun?
It's a halogen light, so it's not quite as white as the sun.
It's nowhere close to the sun. Halogen emits a single wavelength.
Well, but I mean by halogen, I mean a
So how would
tungsten
you have
filament.
any dispersion, Jesse?
No, it's not a discharge. It's not a gas discharge lamp. It's a hot tungsten black body radiation light source with a little bit of halogen in there to keep the filament from evaporating so fast. So it's a broad spectrum. It's not just a single wavelength.
I do not think that's dispersion. I'm sorry.
Well, I mean, there's a blue fringe at the top and a
Yeah,
red
there's
orange.
also red on the side too, right?
Well, the camera's tipped. So if you were to see how the horizon line of the snow is kind of
Oh,
tipped.
there's red on the side of the light, on the right-hand side of the light.
Yeah, there's some lens dispersion.
Why would it be
also.
over there? Lens
Well,
dispersion.
There's some lens dispersion also, but that's going to happen all the way around. The atmospheric dispersion is because of it only happens in one axis. Because that's my theory anyway.
Yeah, I'd have to see the fucking full video for this shit, dude.
Oh, sure. It's lanolins. I'll get it for you.
This is only 6 miles. I thought.
Just give me 1 second. I will get you the video. I time-stamped it to somewhere near there. We're near where I got the screenshot, a little before actually. So if you let it play for a few seconds, you should find it. I did enhance, I did brighten the, increase the contrast, but that's all I did.
How do you know what lamp his fucking snowmobile has?
Oh, we could ask them. Halogen lights are, I'm a mechanic, so I know halogen lights are very, very popular for that application. And since he was not using like the very latest snowmobile there is, it's quite unlikely he had any gas discharge, light.
Could be a LED.
And it's also unlikely it was converted to LED, but we can ask him, definitely.
Are you just
It's
guessing,
final.
dude, or so you don't know, you're guessing?
But it doesn't really matter. It's putting out all the colors. I mean, we can see reds, greens, and it met the
Yeah,
fact
it
that
looks just like this looks like regular scintillation to me, man. You just cherry picked a frame.
It looked to me like there was a strong predominance of the blue on top. But anyway.
That's subjective. I could measure this in something. So why would there even be this type of refractive effect on a frozen lake?
Well,
especially at 6 miles.
If the ice was significantly colder than the air, which is possible on a clear night, the blackbody radiation could chill the ice faster than the air because ice has an emissivity of almost 1. So if the ice was colder than the air and it formed a strong bottom dense gradient, that would be curving light downward towards the ice, and that would be curving the blue light downward farther, which would make the blue part appear higher.
This is what I'm talking about, this curving up and down. What makes you think light does anything like that?
Because light has been measured to go faster in less dense air and slower in more dense air, and because light travels as a wavefront.
That's great. That's conceptual. I'm not talking about concepts. I'm talking about in terrestrial observations. You guys think, so you guys just, look, bro, the conceptual idea is that there's a spherically symmetric atmosphere with a vertical temperature gradient and a vertical density gradient. And by that sheer fact alone, that a spherically symmetric atmosphere with a gradient, light is just automatically going to curve. Right?
I'm not sure what you mean by what did you call it? A spherically
symmetric. Spherically symmetric.
I don't know what that means. I know what spherical means, and I know what symmetric means, but
the atmosphere is curving.
Think like an onion, Jesse.
The density gradient is not a straight line; it's a curved path. Remember?
Oh, you mean on a globe?
Yeah, on the globe. Yes.
Okay.
So it's automatically going to curve conceptually. It has to. And in fact, Andrew Thomas Lunds talks about this, is that it would be impossible to have any type of straight line mathematically. Because if you have it completely horizontally, what would happen is that if you had a ray, it would get trapped at the boundary of the density gradient and form a perfect circle that goes around the Earth. Like say you had 30 degrees and 31 degrees, and at the boundary of the 30 and 31, you had a laser and you shot it. In a spherically symmetric atmosphere, it would duct all the way around the Earth, come back to the same place.
Oh, are you talking about-
Mathematically, in the mathematical, listen, I'm talking about conceptually in a mathematical model. So when you start talking about, hey, light's bending down, that's just that's because you're assuming spherically symmetric atmosphere and a whole bunch of shit. It's conceptual. What's the data say about what light does? You don't know. None of you globe earthers know, because none of you have ever bothered to go look at the literature. The actual literature. When people have gone out and tested it, it doesn't do what you guys think. I'm sorry to tell you that. And you guys spent years arguing about it. What do you think I did? The thing I just read you, Jesse, do you think I just made that up? Do you think I called this chick fucking 20 years ago and told her, hey, write this down? For over 300 years, hundreds of models were created describing the influence of refraction effect on the results of geodetic observations. So far, no universal solution has been found which fulfills the precision requirements of geodesy. So when you sit here and say light would do X, you're implying that you have some universal solution to what the light does. And that you know what it does. And that whatever your answer is of what it does, it's true. It's just universally valid and accepted. Experimentally, no. I'm ripping the whole rug out on this shit, dude. There's no valid justification for any claim of refraction, no matter what it is. Okay, I mean, Jesse, do yourself a favor. Okay, go on Pablo's Dog's channel. Do you know that channel?
It rings a bell vaguely, but I couldn't say I
He's
would
been
know where to
going
find it.
to the same spot in the same parking lot for 3 fucking years, and every 3 days taking video and doing a horizontal pan across Santa Monica Bay. Okay? The shit he's seeing is just it's unexplainable observations. Just unexplainable. Flat Earth or globe Earth, dude. Literally, like one of the observations, it's like an inferior mirage of something that's past the horizon, and an inferior mirage of like a double inferior mirage. There's all sorts of crap he's got videos of. And there's a whole bunch of other people that have, like Heath Carmody and fucking, there's flat earthers that aren't in our little circles. They're out there doing observations, right? Repeated, controlled observations over and over and over again, and none of them match any model of anything. There's no justification for any claim that the light should be doing X, Y, and Z, and that then there's have you ever seen any of the data where they actually take the meteorological conditions and then do the surveying and then try to match them to see if they match up?
I'm sorry, I was trying to find Pavlov's channel. Say that again?
It's called Pablo's Dog.
Yeah, there's a bunch of YouTubers that got that name because it was a famous term
I'll
from.
get you one.
Yeah, thanks. And of course, that YouTube hides the flat Earth ones, so it's hard for me to find the correct one.
Okay, there's that.
Oh, thank you, sir. There, I subscribed to him.
Cool. I mean, not a lot of flat earthers even know about this guy. And there's other ones. There's a whole group of. There's Plain Truth and what's his name? There's a whole bunch of flat earthers that just do observations. They're not really into the. I mean, they got YouTube channels where they post their observations, but they're not into debating or going on freaking Twitter or anything or TikTok or whatever. They're just out there just like doing their thing, dude. So there. Anyway, I'll just bring up this one. Hold on. There's one called empirical modeling by trigonometric heighting. That's one study that was done in Greece. Dude, it's even on McToon's. McToon has a refraction section on his website. Apparently, he's never read any of the papers that are in it. So there are 3 or 4 that are on there where they actually took the meteorological conditions while they did their surveying observations, and they never match up. They just don't match up. Like what they observe doesn't match up to what should be with the meteorological condition, according to the way everybody thinks refraction works, should be one thing that makes their observation this other thing. But they never match up. They're just completely they're uncorrelated.
Could you drop a link to that? I would be interested in reading that for sure.
It's probably on McToon's fucking site. Hold on.
Was that the Romanian Rhapsody I heard?
Oops, hot mic and.
Hey, Wild Bill, it's good to see you.
Hey, Jesse. It's better to be seen.
McToon does have it on his page. Moron. Apparently, he never read it.
Thank you.
That's just one. I mean, it's a whole. Jesse, I don't know why you're just discovering this now.
Well, better late than never, right?
Yeah. Here's a graph from it. This is the survey observation and the meteorological observation. Completely unfucking correlated. Then they try 3 different models to try and fit it, and it don't work. So what do you got against like a laser test, like going out and doing a laser test like 100 days in a row, the exact same time, the exact same place, the exact same methodology, 100 times in a row, some crazy distance. Because like FE core, that's like one of the things like people, it just like goes right over her head. That's not one test all done one night. And to say there's some freakish meteorological condition that allowed it, well, it happened again 3 weeks later, and their meteorological stations didn't pick it up because they have different weather conditions each time. But for some reason, each time lets them frickin' shoot a laser 40 kilometers.
Well, to me, the first step of any form of measurement is to get consistency. And the laser tests don't work every time. And in
Give me
my
an example where they didn't.
there was actually, if you watch the FE Core video, there was one where they could get it to shoot over the observer's head, but every time they tried to bring it down to get it to actually directly hit the observer, it would disappear. But
So, Jesse, put 2 and 2 together, mate. It goes
not
over
true.
the observer's head by 8 foot. It's supposed to be 600 foot or some ridiculously high distance. Oh, wait up. Refraction, I forgot. Yeah, my bad.
Yeah. So the difference between what they observed and the prediction is 2 orders of magnitude, Jesse. You know that, right? You know how large of a difference is the prediction. If you have a prediction and the result is 2 orders of magnitude different than the prediction, there's a problem.
Yeah, I know. I myself have measured circulating ray conditions and even sharper than that.
Circulating ray conditions. What, in your spherically symmetric atmosphere that don't exist? What do you mean circulating ray? How do you know the ray's curving at all?
Well, when I measure an elevation angle to the waterline on a ship at 7 miles and it's 36 feet above where it should be.
That doesn't mean the ray's curving, though.
Well, so how
it just means that the angle of arrival at your camera was displaced. It doesn't mean the ray curved. It could have moved up and down, left and right, all over the place before it entered your camera.
So how could a straight ray that started out below me...
Because light is not rays, dude. And light in the air is... I've never showed you this. I've never showed you the turbulence, the fucking... Oh my God, I'm almost positive I've showed you this, Jesse. I'm almost 100%. Maybe not. Look for something. I'm looking for something. Just give me a second. Look for a graphic. It's this. Oh, okay. So look at the graphic in the chat, the diagram.
All right, scintillation in action.
Can you hear me?
We hear you.
Okay.
Hold on, dude. We're having a conversation.
Do you believe? Do you believe that the Earth is flat?
Wait your turn, dude. Okay. This isn't simply turbulence. All air is like this. It's packed with these bubbles. And what happens is it's the wave front that gets tilted. Okay? If the rays so the ray approximation model is only good for short distances. Did you know that? It's only valid at short distances. It's a simplification to make for lens design, like the thin lens approximation and all those things. The geometric optics, it's not meant for long distance stuff. anything like that. It's not like I can give you a professor saying that it's just. So what happens is you have light that comes off of something, and there's a wavefront, right, that comes toward you. But as it's passing through these bubbles, it's wobbling back and forth. In the angle at which it hits the camera, if it hits the camera tilted like at a 45-degree angle, an object in the distance will appear higher or lower. The ray didn't traverse a different fucking path. It still went to you straight from the source to you. It went in a straight line, but because the wavefront is distorted, it isn't a direct proportional image to what's out there. And I'll show you another one too. It's from another thing. Now these all are from surveying. The first one came from them trying to figure out how to survey in tunnels, because tunnels have the problem where the walls are warmer than the center, so they have a horizontal displacement, and they had to figure out how to deal with that. And of course, they do a bunch of modeling. Okay, so just 1 second. Okay, so. Make sure I get the right one. Okay. No, this is from another paper. This is from the dispersion paper. You see how that says centroid shift? So the centroid would be, say you were on a crosshair, say you're on a bullseye out there.
Right.
But it's going to appear shifted because the wavefront. So say you have a bullseye, and the bullseye is a plane, right? What happens if you took that bullseye now, just with no refraction, just normal situation, and you tilted that bullseye at a 45-degree angle backwards? That bullseye is going to look smaller, right?
Is the
The
bullseye
top is going to look like it's lower, and the bottom is going to look like it's higher. I'm just saying hypothetically.
like a target in the distance gets leaned
Yeah,
over?
like a target.
Yeah.
Yeah, like whatever. If you're looking at some plane in the distance, its orientation, say it's 90 degree, you're looking at it perpendicular. So the light from that is coming at you. It doesn't stay perpendicular. The wavefront gets distorted and twisted like this, like in this graphic. And then when it arrives on your camera sensor or your eyeball, it's at a tilted angle from when it left, right? So like the bottom arrives closer before the top or some other thing. But these little peaks of the waves, that's what actually activates the sensor or the fucking the epithelial cells in your eye. It's the peaks of these frickin' wavefronts, because that's where the energy is. But what I'm saying is, just because something appears displaced, and there's a guy that worked on this for the U.S. Geological Survey called Fred Bruner, okay, and he gave presentations on it because the ray optic model doesn't work, and it's never worked, ever. In 300 years, it's never worked. So he tried to come up with a different methodology, doing the angle of arrival, meaning if something appeared displaced up or down, that meant that the angle that it entered the camera was different. It was at, like, say something would be in the center of the camera. Let's say it arrives at an angle 1 degree higher than the center. What is that image going to appear like? it's going to look at whatever it is that was going to be in the center is going to appear higher.
Right.
But it's not actually higher. It's the angle that it entered. It's the angle that the light entered into the camera.
So I'm trying to understand. Are you saying basically that the light took a straight path from the ship's waterline to me, but then 2 feet in front of my?
No, I didn't say a straight. Look, I didn't say necessarily a straight path. It's wobbling. It's moving around. This wavefront is it's like scintillation. It's shimmering. Well, like these are oversimplifications. What's happening is it'll go into a bubble of one refractive index. I'll show you. I already did show you of what actually happens. Is that hold on a second, because it was in the first paper I posted. What ends up happening is that the light will oscillate around a mean value, right? So you have the straight line value, but as it travels from point A to point B, it's going through these pockets of air and it's moving up and down, right? And these air pockets, these bubbles. So let's say it goes into the air is full of these like bubbles, like in my graphic here, like in the graphic here from the surveying, right? When it enters into one bubble, the wavefront shifts and tilts. Then when it leaves the bubble, it tilts back, but doesn't tilt back all the way. Then it enters another bubble, tilts, and it's doing this the whole time, going from source to receiver, whipping back and forth. And then you're going to catch it at one point in time. It's going to look a certain way, depending on how the air is, the condition of when you receive that light, the condition of the air. You know this if you've gone and done observations, that you could come back an hour later and everything looks completely different. I know this from my observations. I got a fucking observation of a windmill where you can just see one blade barely sticking out from behind something, and then an hour later, I can see the windmill completely as fucking clear as day, all its blades, everything.
So do you think on that one day that all you could see was one blade, that if somebody had a laser?
It was an hour later, Jesse. It was an hour later. It was the same day.
So do you think at that moment in time when all you could see was the top of the top blade, that if there had been somebody at the base with the laser, you would have been able to see the laser?
Well, no, because
Okay.
the base is behind trees.
Oh, it was
I'm
trees.
talking about the top of the blade. Like, look, the one where I could see the whole thing, I could see the hub in the three blades. The one where I couldn't see it, all I could see is a blade faintly sticking out from behind the trees.
What does
And
this
there's also radio towers which I could not see at all at first, and then when an hour later when I took the pictures again, I could see two radio towers. They're tall ass radio towers. They're fucking hundreds of feet tall. They're like twin towers that I couldn't see at all.
Okay, so
I did observations. So there was a buoy, and it was rocking back and forth, right? So the top of it was rocking toward me, and then away from me. And when it rocked toward me, I could see it, and then when it rocked back, it completely vanished, as if it was like disappearing behind a fucking wall. It wasn't bobbing up and down. It was rocking back and forth toward me and away as the waves pushed it, right? The waves push it and it rocks forward, and then it goes in the trough and then it rocks back, right? So it's rocking back and forth. And the tip of it's going into whatever, and it would disappear, and then it would rock forward and then it would reappear. Then it would disappear, then reappear, then disappear, then reappear. It's very strange. Anyway, the point of this is this curved fucking ray shit, there's no evidence for any curved rays. Okay, the curved ray claim is the Earth is a globe. There's a spherically symmetric atmosphere, right? So the ray has to be taking a curved path to go around the globe. There's no evidence for that at all. There's no justification for that. It's just like Earth's the globe. That's what must be happening. That's it. That's the only thing there is to that.
So where did the 2.5 arc minutes of upward angle come from?
I
that
just told
had?
you. I just told you. You don't understand it, dude. It doesn't mean a curved ray. It just means the path is bouncing up and down, dude. Okay,
Well,
Jesse. Can you draw a sine wave?
yes, approximately.
Okay, and where the camera sensor intersects that sine wave, right, is going to determine where it appears on the sensor. So you might intercept it at the peak and then it'll appear higher, or you intersect it at a trough and it'll appear lower, right? That's not a curving line, though. It's a straight line. Well, it's not
sine wave?
necessarily a straight line. It's a straight path that's oscillating around a mean value. The mean value would be the straight line, and it's oscillating about that straight line, deviating. And all the evidence says that this is the case.
Oh,
All
so
the measurement evidence.
So you're saying that, tell me if I got this right or wrong. You're saying that the path of light coming from the ship's waterline to the camera was following kind of a sine wave pattern up and down, but otherwise basically straight. And I just happened to be at a portion in that the length of that sine wave that caused me to look up at it. And if I had moved forward or back, a half a wavelength, then I would have seen the opposite angle.
Yes. Now that's an oversimplification. Okay, obviously it's not a fucking pure sine wave.
Well, what's the wavelength of this sine wave? It's steady.
Depends on the size of it depends on the size of the inhomogeneities of the air. You see I showed you these. Did you not see these? These little bubble graphics? These don't come from me. These don't come from me. These come from the surveying literature. I didn't make these graphics, dude. I'm not making this stuff up. This stuff doesn't come from me.
So, what would be causing the specific
turbulent cells make the wavefront oscillate around a mean? Okay, I don't know else how to describe it.
Is it the density of the air in the cells, or is
it's changes of temperature, density, and they're in motion.
The fuck?
And the thing is, the size of these, it isn't going to be like one size. There's going to be all different sorts of if you could see them, it would look like a foam, right? The air is more like a foam, but there's all sorts of meteorological conditions that affect it, right? Wind, fucking temperature of the ground compared to the fucking air, crosswinds. The point is, it's that the spherically symmetric model has no justification. That's my point. That's my only point. There's no justification for K values or anything like that. What is the K value? It's, hey man, this thing is up 2 inches. And the only way this would be up 2 inches is if the light ray was this much bigger than the fucking globe Earth that we of 3,959 mile radius. So we're going to come up with a value that's the ratio of that 3959, and we're going to say the light ray curved that much. But that's just bullshit, dude. The light ray didn't take a fucking continuous curved fucking path. They just do that as a simplification. And they even say it, that it's a simplification. But do you know where that's got them, that methodology? Fucking nowhere. Because like I read earlier, for over 300 years, hundreds of models were created to describe the influence of refraction effects. So their methods don't work. You understand that you guys, I don't know why I keep saying you guys, but globe earthers or the anti-flat earthers that argue this topic and bring up refraction, they're literally bringing up a failure to justify the globe. No refraction model can make any fucking prediction, period, other than like Snell's law on designing lenses or something. I got another one. Hold on. What's the name of that? Jesse, you ever see this one?
Let me look. Oh yeah, Taylor was showing that.
Yeah, you see these values? You know, for MGON, you know how big of a degree for MGON is? Well,
For
one
Miller
MGON
degree?
is 0.0009 degrees. The largest deviation in this data set is 4. So that means the largest deviation that they measured as far as an angle of arrival was 0.0036. Now, do you know how much that is at 25 miles? It's like fucking 8 inches. Right? So, but the most important thing is, remember how I said is that it oscillates about a mean, right? If you look at this measured vertical angle, you see the values. You have the 0 value where there's no deviation, and they oscillate about that. They're not skewed to one side. They're not skewed to the other side, because if it was a continuous curve, they'd be skewed in one direction. Right?
I'm not sure I'm following exactly what you're saying.
The 0 is the straight line path. When it says the blue lines, right, are the measurements of the angle of arrival of what they're measuring.
The absolute angle or the relative to the
The
mean?
angle of arrival, the deviation of the angle of arrival from where it actually is, from the straight line.
The
0 is no deviation.
From total station position 1 to target 1?
Yeah.
TPS 1 is the total station position 1, right? And then
They have more
T1
than one total. They have more than one device.
right? And they also have more than one target, right? And T1 is target 1, right? So, are you saying that total station 1 and target 1 were at the same geometric elevation?
No, they're not at the same geometric elevation.
So one's higher than the other?
No, very. Give me a second. T1 is T1 I think is a retroreflector.
Yeah, all the targets were retroreflectors, I believe. Left by some previous project.
Yeah. Anyway, the point is that the straight line is the zero. All these the measurements in totality oscillate about this zero. If the Earth was curved, they would all be skewed in one direction.
Why would they be skewed in one direction if Earth was curved?
Okay, because you'd have refraction curving the light, right? So you'd always have a deviation in the angle of arrival. Always. There would never be a straight line. It wouldn't be. You see how this is symmetrical? There's an equal amount of subrefraction, if that's what you want to call it, and refraction about the zero. It's evenly distributed.
Are you saying that the zero on this, the 0 milligradians on this chart is
I'm gone, dude.
Jesse,
I'm gone.
if there's a straight line, that's the difference either side of the straight line. If you think you live on a ball tard, the light incoming would predominantly be on one side of the line. You know this. You're acting dumb for some reason. Please stop it.
No, it's just it's been a while.
I thought I wasn't explaining it good.
It's been a while since I read the paper, and I'm trying to remember the context because all he dropped here was the little one screenshot. And if I remember correctly,
Post the paper again if you want.
the paper wasn't about Earth curve or lack of Earth curve. It was about variations to the vertical angle, and so they actually measured the vertical angle.
Yeah.
And then
That's right, Jesse. They measured the light, dude. I don't care about the fucking Earth curve. I only care about they're measuring refraction on whether it exists or not. That's what we are trying to establish. Is it justified of saying there's fucking curving rays, dude? If there was a curving ray, all the most of the data would be skewed on one side of the fucking zero. Because the angle of arrival would be higher. It would always be higher. This isn't like this is the only shit, dude. This is what I'm talking like. Remember what I started with? You guys have read the textbooks, read fucking shit online, never looked at the academic research, and even if the papers that exist, very few of them have actual measurement data in it. And then if you actually sift through the fucking 1 in 100 papers that have actual fucking empirical measurements, none of them, and I mean none, match any fucking goal prediction. None. Zero. And I'm sorry that might bust your bubble, okay? And I appreciate you sitting here and listening to me fucking rant, but the fact is, I'm at the point, if someone says to me, you got to account for refraction, I'm asking why. And people need to justify why I should account for it, and just going, because it says so in the fucking textbook, ain't cutting it. I want the data, I want the evidence, I want whatever that says, yes, you should count for refraction, because yes, this is happening all the time, because we've measured it. Here are the measurements, here's the data that shows, yes, this is happening all the time. Yes, here's the measurement of curved rays. Here's the, like, there's none of that shit. There's none of that. But fucking, dude, we've been arguing this topic for a fucking decade. And some of the fundamental things about this topic that's been argued has never been established to even be true in the first place. Fucking arguing about refraction 1,000 fucking times. Jesse, I'm gonna give you a newsflash. I got into this topic because I was doing work on refraction, specifically negative refraction, not the run-of-the-mill refraction, way more technical level than this shit. And then the Chicago skyline, I saw that shit, and they're like, "This is a mirage. This is refraction." Dude, I've been studying refraction for fucking nearly 3 decades. And I just hear fucking people say this shit that doesn't, there's no evidence for any of this shit. It would be cool if there was, but there ain't. It's just something you guys just say, you're an account for refraction. Flat earthers never account for refraction. Your calculation's wrong. You didn't account for refraction. Okay. Here you go. You account for it for me then. You fix our math. No one will ever fix our math. No, dude. They're measuring the angle of arrival of the light, dude.
But
what aren't you getting, dude?
well, that's what I'm trying to ask about is
Elevation means nothing. Don't say elevation. Because the device is pointed straight at the other device. There's a straight line, imaginary straight line between each of the devices.
You have a clear line of sight. They're just measuring the angle of arrival and how much it deviates.
so was that measured angle as it was read by the instrument within a plus to minus 4 milligradian angle?
They're making continuous measurements. You understand? Continuous measurements. They're constantly. I don't know what the polling rate was.
Every few minutes, I think, except they would take a few minutes off to do a self-calibration on each unit. But what I'm just trying to understand, if you're saying that 0 degrees was the actual measured angle of arrival for total station 1 when pointed at target 1.
Well, there is no angle if it's 0 degrees. What do you think they're measuring, Jesse?
Well, I think they measured the elevation angle to T1 from TPS1 repeatedly, and of course it's T1.
You're on top of a hill looking down into a fucking hole at a landslide across the way.
Okay, so they've recentered these measurements to center them around the average,
So
right?
look at figure 3, the top image of figure 3. They're on top of a fucking hill looking down, okay? So they got a couple things here. 2, 1, 3, 1, 2, 3, and 4. 4 is a vertical tower of thermocouples where they're measuring the temperature.
Yes, that's beautiful.
The vertical temperature profile. Right, so they're just pointing down into the landslide, dude, and measuring the angle of arrival that the fucking laser hits them, that the laser hits the total station. That's it. It's not fancy, dude.
Okay, so I think we agree that the total stations were pointing down significantly more than 4 milligradians, right? At their targets, at least for target 1.
Yeah, it doesn't matter what they're pointed down. They're only measuring the light. They're shooting a fucking laser off of something and then measuring the angle that it comes back. It knows the direction that it's pointed, right? And they can measure the direction that it picked it up.
So I guess
Jesse, if you fucking shoot like say you had a pistol, okay, and you fired from the hip, the bullet fucking ricochets off a piece of iron and hits you in the eye. Okay, the angle of arrival is higher. You know that the angle of arrival is higher than when it fucking left your gun. Okay.
Because the shrapnel or the piece of metal is falling
Because
as it
it left at hip level and then arrived at eye level.
what's the
So they're shooting
significance of this?
because they're just shooting straight at the prism, and then measuring the reflected light what the angle was, where it should be versus where it is or where it appears to be. These are like infrared, dude, bouncing infrared light off of reflectors.
Right, yeah, most of my total stations also bounce infrared light off of reflectors. One of them uses a visible red laser, though. But, so are we in agreement then that the actual elevation angle measured by the instruments to the targets
Mean nothing. That's what we'll agree to. They mean nothing. We've already established that.
Dude, I don't care if they're looking fucking down from the top of the Empire State Building.
Well, I guess I don't understand
This
what
would
you're
be
arguing.
even worse. Look, bro. This would be my argument. My argument is here's data, right? Of the very little data on refraction measurement data we actually have, right? Because if I ask you to post some, you won't have any. You know that, right? You'll have none.
Definitely not this much.
I posted 2 things. You got 1 thing then? I mean, what the fuck, bro? It wouldn't even matter. Whatever you posted, I've already read it. I guarantee it. Okay? My point is that we should be making claims based upon the empirical evidence, not based upon theory and speculation. Okay? And then we go, okay, let's look into the scientific literature and see what's actually been empirically tested and verified. And then you look at the data and it's nowhere fucking near the effect that they say that is said to happen. It's nowhere near it. It's not even close. But people are going to tell us there's these special refractive conditions that can happen that can make the horizon fucking appear 10 times too far away, that can do all sorts of crazy shit, right? Fine. I have no problem believing that. If you can substantiate that it's even possible, which nobody can do. Certainly not fucking possible to happen every other, every single time we go out. Goddamn flat earthers are so lucky. Oh my God, there's the horizon again, 10 miles away. God, am I lucky? Jesse, if you actually are going on observations, I know you've made the long distance observations that bust the globe. You just don't show them to nobody. Just as a sheer probability, dude.
Oh, I've showed them, and I even showed the ones that show concave. No,
They don't show concave, man. They don't show, dude. No, dude. And things are just getting displaced up and down, dude. I don't know how else to describe it. I don't know if a magnifying glass does this.
I have one of those triangular straight glass prisms that's 6 inches long, and it does that. I can hold it up and look through it, and depending on which way I have the pointy edge, it can make everything look higher or everything look lower, as well as rainbowy.
Yeah. Now imagine in between you and something else, there's like 20,000 fucking prisms, and they're all moving around. But they're only moving around a little bit. Okay. Now you're going to end up with an image that'll be displaced 1 second one way and then displaced another second another way. I mean, stars twinkle for a reason.